Okay, so here we go. Next question. You are going to investigate how the pH changes when calcium oxide is added a little at a time to dilute hydrochloric acid. How are you going to carry out this investigation? This is the required practical that you are supposed to know. So pause the video and have a go at this one. Okay, so 3 marks. So I might have done a little bit too much for this, but this is an ideal answer. So you'll be using a pH probe. You need to investigate how the pH changes. So an indicator like methyl orange or phenolphthalein wouldn't be any use because they only tell you acid or alkali. They're really, really good for titrations when you want the end point, but they're not good for measuring the pH. I would use a pH probe, but if you've put universal indicator, that's fine. It's just not as exact. An improvement is usually using the pH probe. I've just started with the improved one. I also put write down the results. You probably don't need to put that, but then again, a lot of people forget to write down results, so it's always worth putting it down. I've said add a small amount of calcium oxide, stir. I could have written down stir until it all dissolves, stir until it has all reacted. Then we measure the pH with the probe again, we write down the results, we keep adding the same amount, that small amount, 0.2 grams, stirring, measuring, writing down, and we do this until the pH no longer changes. That is how I would carry out that investigation. This sort of question is usually followed up with a graph where you will have to add in one of the data points and possibly draw a curve of best fit. For that, the bendy ruler is your friend, but if you want to draw it freehand, that's okay. Do not ever do a join the dots. Always do a line or a curve of best fit. Okay, so that's a useful exam technique for you. Never join the dots. Right, let's move on to the next question. I mentioned chromatography in an earlier video. Here's a nice question on it. We've got a lovely chromatogram here. So take a look at it and then we'll move on to the question. So here we go. The steps needed to carry out chromatography are listed here. All you have to do is put them in the correct order, and they've already given you the first 2. So let's just get this focused a little bit better. There we go. So pause the video and put them in the right order. Once you've done that, you are going to explain which food colouring has the greatest number of coloured substances. So which one of these has the greatest number of coloured substances? Exam technique hint for you. Forget what they're talking about. Which one of these has the greatest number? Just figure out what's got the most. So we're writing that one down and explaining why we've got the greatest number of coloured substances. This is a deceptively simple question. And then we're going to do the solvent front. The solvent front is always a number between 0 and 1. Okay? And you need to do dividing for it. How are you going to do that with those numbers? That's probably more of a hint than you'd get in your exam. So I hope you've paused the video at a few points. If not, you can go back and pause. Actually, let's zoom out a bit and see if you can answer the questions. Off you go. Here we go with the answers then. So for the first one, you will notice I've crossed off the answers that were given. I was given 2 and 3, so I've crossed it off when I've read them. I then look at it. Number 1, leave the solvent to rise up the paper. Might not be there at the start. Put the paper in the beaker. I was all ready to write that down until I saw that I hadn't yet done number 6. Put small spots of food colouring on the start line. To be honest, even if you've not done chromatography, it's logical that you have to have something on a start line before you put things in the paper. And the solvent has to rise up the paper before the solvent will get near the top, which is number 5. So again, you can do a lot of this with logic. Please don't think that you have to know lots of chemistry to do this. The one that has the most number of dots, T, because it has the most dots. It's got the most coloured substances, because it has the most dots, that genuinely is the answer. You get a mark just for saying T, but you get another mark to say because there were more dots on it. Right, number 3. I've not quite finished this one. So 2.3 divided by 8. Nice easy solvent front one. 2.3 divided by 8. But if you take a good look at this, it says give your answer to 2 significant figures. Sorry, the focus really went on that. I really wanted to zoom in on the word 2 significant figures. How many significant figures have I got here? 4. Okay, by the way, you can always use a calculator in your exams, even if you are just using a nice little cheap one like this. Get a small calculator to use in your exam. It's so much easier than having to stop your exam, stop your flow, trying to ask for something. So anyway, 2 significant figures. The zeros, leading zeros, are never significant. So my first significant figure is 2. My second significant figure is 8. But because the third one is 7, I will have to round it up, making my RF value 0.29 to 2 significant figures. Okay, so always remember, you get a mark for following all the instructions and 2 significant figures. Even if you've done the calculation wrong, rounding it to 2 significant figures might get you a mark, depending on the mark scheme. So never ever give up. Right, just 2 more questions to go. Let's take a look at those. All right, this is a lovely one. Put a cross in the box that you think is correct. That's for later on. So we've got the word equation between copper carbonate and dilute sulfuric acid. For standard paper, you are more likely to be told that copper carbonate and sulfuric acid make copper sulfate, carbon dioxide and water. Put this into a word equation. There is your word equation. Okay, this one's a little bit harder, and is more likely to appear on higher. So we need to do a balanced equation. So for this, you need to know sulfuric acid, which is, I'm going to do the answer. So try and pause it and have a go. I'm going to pop it on there because you need it for the next one. So here we go. Is H2SO4. And copper sulfate is CuSO4. Balancing wise. All right, here is my little trick for balancing. Okay, so if you have got a carbonate, see how many carbonates you've got. How many CO3s? I've got 1. So that's going to give me CO2 and the O for oxygen. I need 2 hydrogens, and thankfully H2SO4 does have 2 hydrogens, so bam, it's balanced. For acid alkalis, get your water sorted first and everything else will fall into place, including how to write the salts. Okay, if it was HCl, then I'd need 2 H's, so it would be 2HCl, which means copper chloride would be CuCl2. Anyway, if you're not following that, don't worry. Please don't worry. Calculate the relative formula mass of copper carbonate, CuCO3. Pause the video and, all right, if I asked you to calculate the relative mass of mum and 3 kids, okay, oh no, I better do it mum, dad and 3 kids. So I was trying to be all inclusive and then realised it wouldn't work because carbon and copper are different. Mum has a mass of 12. The kids each have a mass of 16 and dad has a mass of 63.5. What's the family's mass? I bet you could do it. This is exactly the same. So figure out the mass of copper carbonate. Off you go. And I'm going to do the answer in just a second. Right, let's go for the answer. The mass of copper carbonate. I've got dad, my copper, which is 63.5. I'm going to add in my carbon. So add in my mum's mass, which is 12. And then I'm going to add in, I've got 3 lots of 16. Okay, So that is my 3 children or my 3 oxygens, however you want to do it. So once again, always a good idea to have a little cheap calculator. Let's turn it on and let's do the sum. So what do I have? 63.5 plus 12 plus 3 lots of 16, which is 48. Your calculators, you can probably type in 3 times 16 in brackets. Then you get 123.5. So let's pop that in as the relative formula mass. 123.5. Again, if you are struggling with these, just think about them all as being different people. I've got 1 lot of Mr. Copper, 1 lot of Mr. Carbon, and 3 lots of Mr. Oxygen, and they all weigh this much. Notice there's no units. In standard, you don't have to worry about that. In higher, if you desperately want to put in a unit, it's grams per mole. But again, you don't have to. Yeah, so it's just adding up everything that's in there. The other thing that you will need to know for your sums is you do your given mass divided by your formula mass. If you've ever been given a mass and given a relative formula mass, put the mass on top, divide it by the relative formula mass. That'll get you a mark usually. Okay? So don't worry too much about what the question's asking if you're struggling. Just do that sum and you'll get something. Again, that's not a technique for those of you who are really good at chemistry. That's a technique for those who are struggling. Last one. Chemical test to show the gas is carbon dioxide. This comes up most years. I'll be honest, this comes up time and time again. They love this. They also love hydrogen, which is a lit splint, gives you a squeaky pop. But what's the one for carbon dioxide? Hopefully you've all shouted out the answer or paused the video and written down the answer, which is lime water turns cloudy. There you go. So it must be A. Let's put a little mark there. There we go. One last question to do. And this one is basically continuing on from what we've just done. So copper carbonate, I did 1 spatula measure at a time. How could we improve this? Hopefully you've all thought about it and either thought or said, or we've paused the video and written down, that you could measure it out and add 0.2 grams or 0.3 grams. Okay, so we've got an improvement. How do we know the reaction has finished? 2 observations. Exam technique time, because loads and loads of people get this question wrong. Okay, 2. So we're looking for 2 different things. And it's not showing that there's a reaction. It's showing the reaction has finished. So what will we see when the reaction stops? Pause the video, write down the answers. Go. So here are the answers. First one is that the bubbling has stopped. If you write there are bubbles, that means the reaction is happening. The bubbles have stopped when it has finished. There might be some solid left at the bottom because no more can react. The colour has changed. Not that the colour changes, it has changed because again, we're talking about what's happened in the past. This is finished. And you might get a remark for heat change reverses. To be fair, the top 3 are the better ones. But usually when you do this sort of reaction, neutralisation reactions give off heat and you'd find that it would stop getting hotter or it might start cooling back down to room temperature again. So there we go. Hopefully that's been helpful. If you want me to do any more of these videos or if there's anything in particular you want me to revise with you in 2 weeks' time, I want to do the required practicals with you. But if there's anything in particular you want me to revise, please email me with it and I'll either make some videos for you or we'll do it in class. All right, take care everyone. Bye.